Hello students, welcome to my channel. My name is Darshan, I am your maths prof. So in this session we'll be solving some paper 2 style, that means non-calculator style questions of basic geometry. So the questions of this chapter I have divided into two parts. First is the basic geometry and second one is related to the angles. Okay, so first we'll record this video where I'll solve the paper 2 style, that means non-calculator style basic geometry, then paper 2 style angles. And if you see the paper 4 style, that means calculator style questions, there you won't find anything related to the basic geometry. That is the paper 4 is all about the angles only, no basic geometry will be there. So in the paper 4 style question we'll see only angles questions. Clear? So here let's see the basic geometry questions, paper 2 style, non-calculator style. Okay, so first question is, complete the statement, a quadrilateral with only one pair of parallel sides is called what? So we have seen properties of all the kind of quadrilaterals, and the first quadrilateral which we discussed, it was a trapezium. Trapezium is a quadrilateral whose one pair of opposite sides is parallel. So here it is trapezium. Clear? B part, an angle greater than 90 but less than 180 is called what? It is called obtuse angle. The first session of this chapter, that is classification of angles, where we discussed that if the angle is between 0 to 90, that is acute angle, exactly equal to 90, that is right angle, between 90 to 180, that is obtuse angle, exactly 180, that is straight line angle, then 180 to 360, that is reflex angle, and finally exactly equal to 360, that is called complete angle. So these were the classification of angles. So here they are asking between 90 to 180, so that is called obtuse angle. Clear? See the second question. First is the pentagon, four sides are given, and second one is quadrilateral and it looks like a kite, I think. Yeah. The diagram shows a regular pentagon and a kite. Complete the following statements. The regular pentagon has dashed lines of symmetry. So there is a separate chapter for symmetry, but the lines of symmetry and planes of symmetry, basically. In that chapter, there is a very small topic. That chapter, the symmetry chapter, it has a lot more things which are very important, like circle theorem. So here we'll just solve this question, because symmetry questions are you have already done in primary grades also, and if you talk about the IGCSE, every year you will find hardly mark 1 or 2 mark questions, maximum 2 mark questions, and that also in paper 2 only. Based on this symmetry. So it's just the information kind of questions. So let's just solve it here, and when we cover that chapter we'll discuss this in that chapter also. But I think you must have done this in your primary grades also. So lines of symmetry is basically a line about which it is a symmetry. It could be a mirror line, so that on the left hand side and right hand side of that line, both the figures are completely identical. They are just mirror image of each other. So if I draw one line here, it will be a line of symmetry, because on left hand side and right hand side both have the same mirror image of each other. Then this is the second one. Similarly, this is the third one. Similarly, fourth one, and similarly this is the fifth one. So total 5 lines of symmetry are there in the regular pentagon. So 5. Clear? B part, the kite has rotational symmetry of order what? Rotational symmetry means after rotating it, how many degree you can rotate it, clockwise or anti-clockwise, so that the same figure repeats. So if I rotate this kite by, let's say, 90 degree, it will be somewhat like this, right? But it is not same as the original one, so it is not symmetric. Then if I rotate it by, let's say, 180 degree, then it will be, you know, upside down, which is also not same. So in the case of kite, if you rotate it by 360 degree, so the whole circle if you rotate, then only you will get the same figure. Otherwise it will not be the same figure in any angle. So that means it has a rotational symmetry of 1. Out of this 360, only once you get the same figure, and that is 360 degree only. So rotational symmetry of order 1. Clear? Change 1 meter cube to centimeter cube. Now this is just a conversion kind of question. Now it is not just the meter to centimeter, it is meter cube to centimeter cube. You must have done this meter to centimeter. 1 meter is equal to 100 centimeter, we already know that. So if I do the meter square, squaring both the sides, so 1 square is 1 only, so 1 meter square is 100 square is 10,000. So if they have asked you 1 meter square, that will be 10,000 centimeter square, but no, they have asked you the meter cube. So let's cube this, then 1 cube is 1 only, so 1 meter cube. But if you do the 100 cube, that is 6 zeros behind the 1, so that is 1 million actually, 1 million centimeter cube, or you can say 10 lakh centimeter cube. So 1 meter cube is 1 million centimeter cube. Clear? Now in the same way, convert this 32.4 meter cube into centimeter cube. Now we already know that 1 meter cube is 1 million centimeter cube. So basically 32.4 meter cube is, let's say, x centimeter cube. So this x will be nothing but 32.4 multiplied by 1 million. 32.4 million basically, these many centimeter cube. But if you write it in numbers, like without the decimals, it will be 324 and then 5 zeros, 1 2 3 4 5, these many centimeter cube. So it's 324, 1 2 3 4 5 zeros. Clear? Okay, second worksheet. Change this centimeter square to meter square. Now in the last worksheet we have already done the conversion from meter square to centimeter square. This is centimeter square to meter square. Let's revise it again. You can say 1 meter, sorry for that, 1 meter is equals to 100 centimeter, we already know that. So if you square it, so 1 meter square is equals to 100 square is 10,000 centimeter square. Okay, so using this conversion thing, what I can say, that 10,000 centimeter square is only 1 meter square. In that case, 407,000 centimeter square is, let's say, x meter square. Okay, so this is a simple ratio thing. Just do the cross multiplication. This x will be multiplied with 1000. So 1000x, 10,000x is equal to this 1 will be multiplied with 457,000. So that is 457,000 times 1. So this x, which is the meter square, it will be 457,000 divided by 10,000. Sorry, I think I added one extra zero here. Yeah. So 0 cut. So it is 45.7 meters square. So it is 45.7 meters square. Clear? See the second one. Write down the order of rotational symmetry of the diagram. So rotational symmetry is after rotating it by how much degree you can get the same figure, right? So if you rotate it, let's say clockwise by 180 degree, if you rotate it clockwise by 180 degree, this, let's say this end is A and this end is B, so this A will come here and B will go here, but still the figure will be exactly identical only. If I draw it here, it will be somewhat like this. So exactly same, because A and B corners are exactly equal to each other. So there are 4 columns and 4 rows, 4 by 4. I'm sorry if it is not exactly equal to the diagram, because I'm just, you know, not measuring, it's not drawn to the scale. So this, and this, which is also this part, B part, and this A part will be here shaded. So you see this figure is exactly equal to the original figure. And again, if you draw, if you rotate it by 360, then obviously the same figure will be coming. So any figure will have one rotational symmetry for sure, that is 360 degree, because if you are rotating any figure by 360 degree, obviously 360 degree is same as the 0 degree. So you are getting back the same diagram. So that means minimum rotational symmetry of any object is 360 degree, and order of symmetry is 1 in that case. But here, out of that one circle, 2 times you will get the same figure. One is 180 degree and another is 360 degree. So the order of rotational symmetry here is 2. So order of rotational symmetry, that is 2. And if they ask you the degree, then it is 180 degree. Clear? See the third question. The diagram shows the pyramid with a square base. Okay. The triangular face are congruent isosceles triangles. Congruent means identical. So all four sides are congruent. So they all 4 sides are identical triangles, and the base is a square. Write down the number of planes of symmetry. So by how many planes are there if you cut it in half, so that both the halves are mirror image of each other. So it's basically the same as line of symmetry of your squares. So if you just observe a square from the top, so let's say this is a square which is a base of your pyramid, and it has this one line of symmetry. Okay, then there is another line, 2 line of symmetries are there. Okay, and this is the third one, and this is the fourth one. So these 4 are lines of symmetry of your square, and it will be same as the plane of symmetry of this whole figure, because when you are cutting this whole figure like this, making a planes, then obviously you will have to cut the base also into the same equal 2 parts. So in that case, if the plane of symmetry of the whole figure must be equal to the line of symmetry of the base, then only it is exactly identical to each other, the mirror image will be formed, right? So if the line of symmetry of the base is 4 here, then plane of symmetry of this figure is also 4. So write down the number of plane of symmetry, so they are 4. So if you find this kind of questions in any past papers, you will always see that it's hardly 1 mark or 2 mark. So I don't emphasize too much on this line of symmetry or plane of symmetry, rotational symmetry topic, because it's hardly 1 mark or 2 mark. I would say 1 mark only, because 2 mark is never there. So don't focus too much on this topic. If you can understand it very well, then it's fine. If you don't, then just don't mind, because it's hardly 1 mark question in any past paper. Okay, fourth one, the diagram shows a cuboid. AB is 8, BC is 4, and CR is 5. So basically length, breadth and height are given of the cuboid. Write down the number of planes of symmetry of this cuboid. So if you imagine this is a cuboidal cake, okay, and if you want to cut this cake into two equal halves, that cut is called the plane of symmetry. So if I cut it like this, exactly in the middle, not it is like this. So obviously I'll cut it by exactly half. This is a one plane of symmetry, clear? And similarly, second plane of symmetry is this one. If you cut it like this, in the middle, so that will be the second line of symmetry. Not line, sorry, plane of symmetry. In 3D figure it's always a plane of symmetry. So two planes of symmetry like this, and the third one is if you cut it horizontally like this. So if you cut it like this, this is also a plane of symmetry. So there are three planes of symmetry. This is third one. The first one was like this, two, and the third, this third one, first one, and second one was like this. Clear? So three lines of symmetry, sorry, planes of symmetry. Why do I say line of symmetry always? It's a three planes of symmetry which are perpendicular to each other. So this has three planes of symmetry. Clear? This is the third worksheet. Chai says that 8 centimeter square is same as 80 mm square. Explain why Chai is wrong. So first of all, let's get the conversion of centimeter square to mm square. So you already know that 1 centimeter is equal to 10 mm. So if you square it both the side, 1 square is 1 only. So 1 centimeter square is 10 square is 100. So 100 mm square. So if the 1 centimeter square is 100 mm square, so obviously 8 centimeter square will be 800. It's basically times 100. Whatever is the centimeter square times 100 will be the mm square. So 8 centimeter square is nothing but 800 mm square. So he is wrong. Clear? See the second question. The cross section of the prism has n sides. Circle the expression for the number of edges of the prism. This question will cover it later, because yeah, it's a there is a formula for that which will be covered in that symmetry chapter only. So don't mind right now. Just directly go to the question 3. Circle the volume that is same as 15 centimeter cube. So if I want to convert it 15 centimeter cube to mm cube, so we know that 1 centimeter is 10 mm. So if you cube it both the side, 1 cube is 1 only, so 1 centimeter cube is 10 cube is 1000, so 1000 mm cube. So if you convert this 15 centimeter cube, then it will be 15,000 mm cube. If you convert any centimeter cube to mm cube, according to this conversion, you'll have to multiply it by 1000. So 15 centimeter cube is 15,000 mm cube. So the answer must be this, 15,000. Clear? Yeah, that was it in this session. We saw some basic geometry questions, paper 2 style of questions, and in next topic we'll see paper 2 style of questions of angles. Then we'll see paper 4 kind of questions of angles. Okay. So till then, just keep practicing. That was it in this session. And if you like this video, please give me a like button, and share it with your friends who are also in IGCSE. And very soon we are starting AS and A level sessions also. So just keep practicing, and if you find them useful, then share them to your ASN enabled students also, your fellows also. Okay, thank you.